graphs. So last week you guys covered trees, this week we're covering graphs. I think both of these are super common data structures that come up quite frequently in interviews. So definitely take the time to review a lot of the questions that we'll be covering this week and the prior week as well. These two are really common topics that come up quite frequently, in addition to, I think we'll be doing strings and array next week as well. So I think these 3 weeks are probably like the topic that comes up most frequently in interviews. So just definitely review them. If there are any questions that you weren't so sure about, definitely spend some time and just ensure that you understand how the questions are. And yeah, that's basically it. So kind of jump right into the overview. So I kind of just wanted to go over personally my experience with interviewing. I think it'll be kind of quick, but I'll kind of cover the timeline for me in terms of what my experience was when I was in college and what that looked like. And then we'll just briefly cover a lot of the key graph concepts that I think you guys should know. There aren't too many, but it's good to know the terminology, and we have guides on these. So while I'll be going through them pretty quickly, if there's anything that you're not so sure about, I'd highly recommend going through the guides. And we'll do a walkthrough of a graph interview question that I picked out, and then we'll wrap up with some in-class exercises where you'll do them in pairs. So they'll be kind of like pair programming type exercises. Cool. Just as a reminder, if you go through the warm-ups tab, there's actually like a video there this week. So if you actually look at that, if is a graph bipartite question, I actually created a video walkthrough of like the detect a cycle in a directed graph problem, so that could help you with is a graph bipartite problem. So if you kind of missed that, definitely recommend going through that problem if you want kind of some more walkthroughs. Cool. So aside from that, I'll just briefly talk about my personal interview experience. So actually what happened was I didn't start computer science until the end of my freshman year. So I kind of started computer science. I had no programming experience prior to college, and for my first entire freshman year, I wasn't doing computer science. It's a major that I kind of switched late into. So my first internship, or my first experience trying to get an internship, was for my sophomore year summer. So the summer after my sophomore year, just to clarify. So because I started my major pretty late, so I started basically the beginning of my sophomore year, I didn't really apply for internships until the spring of my sophomore year for that immediate summer. So the timeline for me was not so great. So because I was applying this spring for a summer role, a lot of the options were more limited because a lot of companies had filled up their spots for a lot of internship roles. So just in general, I'd highly recommend just starting the recruiting process in the fall if you're planning on trying to get like a summer internship. So just in terms of like how I approached getting my first internship, it's quite challenging. So some of what I did was I actually just went through some of the VC sites and kind of tried cold emailing startups from different VC sites. I was basically just trying to get any internship I could get. So that was one of the methods I approached. Luckily for my school that I was at, there were actually career postings on the school site. So I actually went through and applied to all those as well. And there were still like some career fairs happening on campus. So I tried to take advantage of whatever career fair that I knew was coming up. Just so that you guys know, VC stands for like venture capital. So some of the really top venture capital firms will list all the companies they've invested in, and I kind of use that as a guide to cold email some companies. So with that approach, I actually did get a lot of responses. Unfortunately, a lot of them were not positive responses, but they still got back to me, which was pretty great. And yeah, so that was kind of my experience just applying to places. Generally, I actually didn't hear back from a lot of places. I applied to many different companies, and just in general, I guess the way to look at it is a lot of companies prefer people who are kind of in their junior year trying to apply for an internship in the summer right before they would basically get a full-time offer. So a lot of companies actually prefer junior basically year candidates over sophomore year candidates. So it's not just that it's hard because you're unqualified, it's just that's generally the preference across a lot of different companies. So in general, it is a lot rougher trying to get your first internship just because you don't have industry experience, but also they also do have a preference for junior people in their junior year. Well, so just in terms of like internship interview structures, for those of you who haven't been through it, most of the ones I went through were a ton of phone screens. Some companies were able to do on-sites on my campus, so that wasn't very common, but that was a different format as well. So a lot of, I think, the practice you have in this class will prep you pretty well for all the phone screens you'll have to do for like internship interviews, basically. And some of the kind of like smaller companies, like the more intense companies, could potentially bring you on site. So I had very few of those, but I think I had one. So that does happen for, I think, the smaller companies. Cool. So then I ended up actually interviewing. So after that, the next internship I was applying to was my junior year internship. So for my sophomore year internship, I actually ended up, I think Facebook still had openings and I applied and I ended up getting an internship there. So that's why I ended up doing like as my first internship after my sophomore year. So after that, the next internship I applied to was someone said small companies can afford to bring you on site, and then someone said same question. I only got on sites from huge companies. So I think I'm kind of a special case because I went to school locally in the Bay Area. So for certain companies where you're local, like they'll bring you on site or you're really close. So I think it just depends on the parameters, like where you currently are, and if they're able to bring you on site, there's the potential if you're really local to where they are that they will bring you on site. Otherwise, they might not. And it also just depends on if you're interviewing for like internship versus full-time. So for full-time, generally they'll like, I haven't had like a full-time interview that had no on-site. So for full-time, you'll definitely be on-site. Cool. So for the next internship I had, I started recruiting a lot earlier this time because I knew it was just like that spots were filling up. So I did it in the fall for the summer. I think by the time you're a junior, it's just a lot easier to get interviews compared to the year before. I had experience on my resume now, but also companies just prefer to have like juniors come in. Someone just asked how the interview at Facebook was like. So this was quite a while ago. So I've kind of been in the industry for some time, but from my experience with Facebook, they actually brought some engineers onto campus and I basically did 2 whiteboarding questions. So I did 2 back-to-back, like 45-minute segments for an internship interview. So what I assume would happen for those of you who aren't doing kind of like in-person interviews for internships, which I think are more common, is that they'll probably do like 2 phone screens. That's not like the most updated information, but I think that's generally the case. And so that's personally my experience with the Facebook interview. So with my junior year internship, I started earlier this time, recruited in the fall for the summer. It's a lot easier to get interviews compared to the year before. So I did a lot of the similar things. I went to career fairs. I also tried to get referrals from people I knew who were working at these places. So I'd highly recommend, I think, getting involved in like the computer science community if you're not so. I think back when I was in school, I was a TA and I was also part of some of the computer science organizations. And that's been pretty cool because now I kind of know a lot of these different people at these different companies. And when you know a lot of different people at different places, it's pretty helpful to have a referral because I think having a referral gets you noticed and helps you stand out from the crowd of like all these like many different students who are applying. Cool. So after that, I actually ended up interning at Fitbit. So at that point, I kind of wanted to try a smaller company. So I interned at Fitbit for my junior year summer. So by the time I reached full-time interviews, it was kind of like very similar to my junior year recruiting process where I started interviewing for the fall for full-time positions in the summer. So Similarly, I went to a lot of career fairs. I asked my friends at companies for referrals. And then for full-time interviewing, I think the process is a lot more strenuous. So with internship recruiting, it was a lot less of a commitment, because with full-time, what will happen is you'll do a phone screen, and then after a phone screen, they'll have to bring you on site. So you have to basically dedicate a day per company you want to do an on-site for. So I kind of recommend being aware that, like, if you're recruiting in the fall for a full-time position, allocating some time, or like knowing that next semester you might be pretty busy trying to coordinate all these different on-sites, and you'll spend a significant amount of time doing on-sites. So for full-time interviews, I kind of knew that I was going to have to be doing a lot of on-sites. So how I practiced was, like, every few days I would kind of mock interview with a friend. So I would kind of try to find a classroom or someplace with a whiteboard, and we'd kind of practice going through a question together. So that was really helpful. And just in terms of the structure for the full-time interviews, is you'll have the phone screen and then you'll do the on-site. And for the on-site, I think it depends on the company, but generally there's around like 3 to 4 technical interviews, and each interview can be 45 minutes to an hour. Some places might have more technical interviews, but I think in general it falls in that 3 to 4 number range. Cool. So yeah, with some companies, they'll kind of do like a culture fit interview as well. So in addition to the technical interviews, they kind of just want to make sure that you're a good culture fit, like that they like you, they'd want to work with you. So some companies, for example, back when I was recruiting, which was a while ago, like Airbnb, they actually had quite a few culture fit interviews just to kind of gauge how passionate you are about the product. And like they asked a lot of like pretty random questions. So I think they're just trying to gauge if you'd be a good fit at the company. Someone asks, are there design questions in tech interviews? So with design questions, I didn't really get any kind of like architecture questions. So architecture questions you tend to be asked architecture questions only after you've kind of been in industry and you have industry experience. So no architecture questions for tech interviews for new grads that I've encountered. And I've interviewed at mostly, I'd say, like mid to large companies. So I've interviewed at like Google, Facebook, Pinterest, Airbnb. I also did like Dropbox. I did quite a few companies like LinkedIn, and none of them were asking me like architecture questions as a new grad. Someone asks, how was Dropbox? Dropbox is, so there are many different type of interview questions. Dropbox, because they're kind of like a more back-end heavy company, and I was kind of more interested in back-end work, they kind of asked some parallelism questions. So Dropbox was a pretty unique scenario where they're asking about like threading and stuff like that. So that was a pretty unique experience. So someone asks, how long experience will they ask you design questions? I think there's like a difference between design questions and architecture questions. Architecture questions are like, they're asking you to architect like a system that can handle a lot of load. You might get asked design questions in terms of like, oh, design like a tic-tac-toe game, where they're kind of just testing to see your OOP design skills. So I want to clarify that you might get asked like OOP design-esque questions, but you probably won't get asked like architecture questions, and the differentiating factor is with architecture questions, you're expected to know how to scale to like millions of users, which is not really a skill set you'd gain from school. Yeah. Whereas like OP, they kind of expect you to be able to do that. Cool. So someone asks like, how did I prepare for these interviews? I think with Dropbox, I kind of knew that they were going to do, they actually did, a lot of companies will, not a lot, but some companies, I think, especially companies that are asking more unique questions, will kind of tell you up front that like, hey, we might ask you some threading questions, so you should maybe review that. So with Dropbox, when I was preparing for like threading type questions, I was reviewing a lot. So I took like OS class, and I had that background where I knew I had experience in class with doing threading work. So I would just mostly honestly reviewed what material was covered in class. And I just ensured that I was able to, at least in my classes, they gave us some parallelism questions. So I just kind of reviewed those and make sure I was comfortable with that. Okay, I'll kind of answer some of the last 4 questions. I'm not really sure what gang of 4 type design questions means. I haven't heard of that, so I'm not really sure how to answer that. But someone asks, let's say there are 4 tech and 1 behavioral interview. If I fail 2 of the tech interviews but pass the last 2 in the behavioral, does the success outweigh the fails? I've kind of talked about this in the past before. I think basically what will happen is if it's not clear whether or not it's like a clear yes or clear no, sometimes a few things could happen. One is that they might think that they need more signal, so they'll kind of ask you to do an additional interview, or it's like an additional coding challenge just to kind of gauge what you do, or like to get more signal basically. So if they're like, hey, you failed half of them and you succeeded on the other half, but we think there's like a good chance you could maybe pass, they'll probably ask you for like another coding challenge or like an additional round just to get some more signal. I think behavioral is more just like just making sure that the person is pleasant to work with. So that's my personal experience. Yeah. And someone asks, oh, I see. So do we get questions on specific software design patterns? So I wasn't explicitly asked about those during my experience. So from personal experience, no. And my experience from Pinterest and how we do new grad interviews is I haven't heard of people asking for specific software design patterns. I know it's probably just good to review these patterns and know what they are in case someone decides to ask you really briefly what they are. But aside from that, I haven't gotten asked that. But I think interviews are so broad that potentially, like, if you're interviewing for a job, a specific role, they might ask it. So it's probably good to review, just like at least kind of know what they are. And it shouldn't take too long, I think, to review design patterns. Yeah. Cool. Sorry, I'm speaking mostly from personal experience and my experience being on the other end at one specific company. But I think the interview process can vary a lot depending on like the company you're applying to. So I'd say for things that are kind of quick to review, I think it's just safer to review them in case it comes up. And with design patterns, I think it's pretty quick to review all the design patterns. Cool. So just some personal insights. Yeah, from personal experience, I've been in interviews where I was like interviewing and it turns out I was trying to solve the wrong problem. So that's really kind of crappy. And it basically, like, I'll get to the point where I'm telling my interviewer how I'm going to approach the problem and it turns out I'm trying to solve the wrong problem. So I think it's bad to just rely on the input and output they give you. And instead I should, like, personally, what I found is really helpful is coming up with my own input and output so that I'm just verifying and validating that I'm solving the right problem. So yeah, coding in front of an interviewer is really intimidating in general. I think generally what happens is like the first onsite you have, or like the first 1 or 2 onsites you have, if you have multiple, it can be really intimidating. So what I found is that the more kind of like on-sites I was doing, the more comfortable I got with it. So sometimes what people will do is if there's like a company they really, really want to go to, they'll schedule that a bit later. And like the companies they're maybe somewhat less excited about, they'll schedule those earlier. So that way, like by the time you're reaching the company, by the time you're interviewing at the company you want to work for the most, you've kind of gotten maybe hopefully some of the nerves out of your system. So that's what I've seen people do. And generally that was kind of the approach I took as well with applying to companies and like structuring my on-sites. So aside from that, practicing with friends is really helpful. I think it gets you comfortable with being uncomfortable, and at the very least, I think getting comfortable with that feeling is a very helpful skill to have. So other than that, I've actually gotten feedback from people I've interviewed with when I was interviewing that my code on the whiteboard was a bit messy and hard to follow. So the other benefit of practicing with a friend on a whiteboard is that I think you can get some practice with like proper code organization on the whiteboard and like figuring out like kind of how to structure your writing so that it's readable and easy to follow. And aside from that, I think the last thing I've kind of like learned is like pseudocode is really helpful for structuring the code. Sometimes all my thoughts are in my head, but if I just kind of like write it really quickly, my general thoughts, it helps me. And it helps me especially because like I'm nervous, I might be forgetting things, but having like some structure there to follow is really helpful. And lastly, like there's just like a few whiteboard tips that I've talked about. So yeah. And the last thing I think is some, I think, newer interview formats that I've seen that was a little unexpected is like sometimes you are just kind of given a code base and they're kind of you're asked to debug that code base. So that's kind of something that I think is more recent and I think becoming a little more prevalent in coding interviews where they'll kind of give you that repo and they're just kind of wanting to see like how you go about debugging your problem. Cool. So I had reviewed some people's resumes. So what I think looking through a lot of people's resumes, I like that a lot of people put the side projects. So based off of personal experience, interviewers will actually read your side projects, and if they find it interesting, they might ask you about it. So it's definitely a good skill to have to be able to talk about your side projects. And just in general, I think when you're structuring your resume, try to put kind of like the most interesting and more complex projects up on top in your project section, because what happens is when I'm scanning a resume, I tend to notice the first thing in each section. So if you, for your like most impressive project, I probably put that up on top so that it kind of, so that like other people will notice it. And someone asks how to prepare for such code-based interviews. Yeah, so I think the debugging question is, it's honestly pretty challenging in general. I think more or less they're trying to understand how you go about trying to break down a big code base. So if you are not super comfortable jumping into a big code base, maybe what I'd recommend is if there's like a few big libraries that are open source, maybe just going through those and like trying setting up that library, looking at that library, and maybe playing around with like a new code base is really helpful. In general, I think just being cognizant of like what techniques are really helpful when you debug is also really good. So a lot of people do really well like print debugging. So I think it's also like, how do you approach debugging in general? They're more or less just saying like, ideally you've done a lot of debugging throughout your kind of like career, through like classes, through like maybe your previous internships. They kind of just want to see how comfortable you are kind of doing that in front of someone else. Yeah. Someone asks, should I have a different resume for recruiters than interviewers? Like for a resume, it will be more skim ready, while a resume during an interview will have more detail for an interviewer to read. Yeah, so from my experience, the resume you submit to the recruiter tends to be passed down to the interviewers. So like when I'm at Pinterest, basically what happens is the recruiter I'll kind of log into a portal and the resume I see is actually the resume you submit on there. So what I just recommend is, I think you generally won't have the option to like give someone else like a different resume than the one you submitted online. So be careful about what you submit online, because that's probably the resume that everyone will look at. Yeah. Oh, in terms of side projects, so towards like later in my like junior year, I did a lot more hackathons. So I kind of did so a lot of like the projects that I put on were like the projects I worked on in hackathons. So they were kind of pretty random. So they kind of, one was like I think like one project I did was like using the webcam to like, so like I can talk about it really quickly, but basically like everyone has like a unique iris. So one hackathon project I did was with a group of people, was just like using your webcam and like logging in based off of your iris. So that was kind of like a fun project I did with some friends, and that was like one of the projects I put on there. Yeah. Cool. Aside from that, if you kind of have specific questions you want to talk to me about, feel free to stay at the end of class or even just ping me on Slack. I'll try to kind of respond within a day usually. So we'll kind of just talk about graphs really quickly before diving into a question. So I'll kind of be going through all of this really quickly, but once again, it's all in the guide. So if you want to review it, it'll be there. I'll also put a link up to the slides. So if you want to review the slides, it'll be here as well. But graph is pretty simple. It consists of like a set of nodes connected by edges. So I have a simple picture of a very simple graph. Oh, sorry, did not mean for that to happen. Cool. So, oh no, sorry guys. Okay, so the two types of graph you should be cognizant of are that like with these edges, there could be potentially a direction. So with graph questions, you might be given a directed graph or an undirected graph. So an undirected graph means that the edge is basically bidirectional. Yeah. And then the other terminology that comes up really common is acyclic versus cyclic graph. Acyclic means there's no cycle in a graph, while a cyclic graph means there's a cycle. So even though kind of these two graphs look really similar, if you notice in the acyclic graph, there's no way to kind of, if you start off at the zero, there's no really real way to reach back to that zero. And if you were to repeat that with every node, that would yield the same result. Whereas in the cyclic one, you can see that with each node, there's a way to reach back into that node. So that's another common terminology to know about. And just in terms of graphs, aside from those kind of common structures and those common phrases, you should kind of be wary that there are a few ways to represent graphs. So one way to represent graphs is you can view it as like an adjacency list. So what that looks like is you'll have a node, and then a graph is kind of like basically stored in a dictionary, and for each node you have a list of the nodes that are its neighbors. So in this case, like for example, node A directly has B and C as its neighbors, and you can kind of repeat that with each node. Cool, so the other representation is simply just representing a graph in terms of all the edges that exist in that graph. So in this example, this graph is just broken down to all the different edges that are there. And the last one is an adjacency matrix. So this is a bit harder to read, but you can kind of represent a graph in terms of like basically the edges that exist between the graph, and you can represent that in a matrix. So in a simple example, let's say that there's an edge between 0 and 1. If you look at this adjacency matrix there, the value is set to 1 because there's an edge that exists. And for all the different other combinations or pairings of the nodes, if there is no edge that exists between it, it'll be set to 0. So those are the representations of graphs I've seen, and I think it probably is a good idea to kind of just review the different runtimes associated with the different graph structures. So I've kind of outlined it here. I'll have a link to the slide so you can review it really quickly. Just in general, for runtime analysis of graphs, it's good to distinguish between like vertices and edges. So just in general for runtime, I think the best way to approach runtime for graphs is to split it up in terms of like the vertices and edges. So you can see how that's done kind of in this chart right here. But just in general, what I've seen from personal experience is that adjacencies lists are the most common, and they're kind of like the easiest to work with. So I've seen that representation the most common. Cool. So just in terms of like the types of graph questions, there are two. So one is that it'll be explicitly stated in the interview question that you have to work with a graph. So your interviewer will be telling you, hey, you have a graph, like, how do you do this with the graph? So in this case, I think there are some good clarifying questions you can ask. The one I would ask if it's unclear is this graph directed or undirected? So depending on that answer, that can change like how you approach the question very differently. And the other question you should be, I think, if they don't make it very clear is, will there be a cycle in this graph? If so, that will require a lot more probably handling that you have to do on your own. But if the interviewer tells you there's no cycle, that makes your life a bit easier. So it doesn't hurt to ask this question if it's unclear. So the other type of graph questions that are also actually very, very common is there's no mention that the question is a graph question, but the problem can be framed as a graph question. So I think the best way to think about it is if they're like binary relationships between objects, those can tend to be modeled as like nodes and edges. Aside from that, like, for example, like if each box in a grid is a node and there can be edges between neighboring boxes, that's like one example of a scenario that can be modeled as a graph question. So a lot of like common themes I've seen in graph questions are like when they asked about like dependencies, that in your head you should think, hey, this is potentially like a graph problem, basically. And also like maze questions are really common, and those tend to be like problems that can be solved with like a BFS or DFS. So maze questions can be basically viewed as a graph problem. Cool. So aside from that, we'll just kind of pretty quickly go through graph traversals. So there are two that we'll talk about. The first is like a depth-first traversal. You'll start with an arbitrary node as a root, and then you'll just explore each child fully before exploring the next one. So in here, I've kind of walked through what a depth-first search would look like. If you start from node A, you'll kind of just very deeply explore basically as deeply as possible. So you'll go to B and then D, and then you'll go to C and then E. So you're basically just traversing as deeply as possible before you kind of explore the next branch. So I put the code up for depth-first search up here. It's actually pretty straightforward. So if you're not super comfortable with it, I'd highly recommend you should basically know depth-first search and breadth-first search like very, very well by the end of this week. So with breadth-first traversal, you basically pick an arbitrary node as the root, and then you explore each of its neighbors before visiting their children. So in this example, you'll start off with node A, then you'll go to B, and then you'll visit C and D both before you eventually go into node E. And the way breadth-first traversal is you're kind of just effectively going layer by layer. And here's the code for breadth-first search as well. It doesn't look actually that different than what I just showed. So you should also kind of know how to do a breadth-first search very, very well by the end of this week. So just in terms of like a DFS versus a BFS, the thing to note is people, I think, generally prefer, it depends on what you're comfortable with, but a lot of people kind of prefer DFS. I think DFS is really good for analyzing structures of graphs, like you're looking for a cycle. DFS makes that pretty easy. So in terms of like when you would use a BFS just is generally good for like optimization because you're kind of looking at things like level by level. It's really great for like shortest path algorithms. Cool, so I walked through those really quickly, but I wrote up guides for each of these things. So I'd highly recommend you go through the guides. You should be super comfortable with traversals because basically a lot of the questions you'll be given for graphs are just like, how do you perform a traversal to solve the question that we're giving you? Cool, so the question we'll kind of do a walkthrough of today is the clone graph question. So with this problem, I believe I put it up here. Let me see, 1 second. It should basically be in the session 1 tab. I put it here. It's a question that I kind of want people to spend around 20 minutes trying to tackle. So I'll split you guys up into groups of like 2 people. And ideally you guys go through, read the question, try to think of how you would solve that question. And by the end of 20 minutes, ideally you have some pseudocode written down. And if you have more time, then jump into trying to implement that code. So before you kind of jump into it, kind of think about the clarifying questions you want to ask. In this case, can the graph have cycles? And like, are the labels unique for each of the nodes unique? So for this one, I'm not sure if it's clear in the question, but yes, it is possible for a graph to have cycles, and the labels for each of the nodes in the graph will be unique. All right, so with that being said, we'll have someone, sorry. Oh, someone says, if there are multiple neighbors or children, do you just select one at random to explore? So if you look at the question, we can open it up just to kind of make it clear what the question is. The question is basically asking, you're given a reference of a node and, oh, sorry, I had my answer there. But basically, you're given a reference of a node in a connected undirected graph. So explicitly, they tell you it's an undirected graph and the graph is connected. So basically, all the nodes will be reachable from this node you're given. They ask you to return a deep copy of the graph. And in this case, they actually, sorry, I'm like most familiar with Python, but they explicitly show you what a node will contain. So they'll give you a starting node, and within that starting node, that node will have access to its list of neighbors. So that's kind of what you start off with. So they give you this node, and that's kind of what you work off of. Cool. So with that being said, I'll give you guys around like 20 minutes to try to solve this problem, and then after that, we'll kind of sync up and I'll do a walkthrough of this problem. In that case, Elena, can you break everyone out into groups of 2?
Oh, sure.
Hi.
Oh, hello. Okay. Cool. So yeah, so I was kind of able to jump into some of the rooms. Just a reminder, sorry to like repeatedly say this, but it's really helping BFS and DFS. Yeah, so someone mentioned like stack space size of input. That's a good answer. So just thinking about like how big the queue or stack can grow, it can grow basically with a BFS, the queue of nodes you're queuing up can grow really big. I think it just depends on the structure of the graph. Aside from that, I think depending on what your comfort level is, some people are more comfortable running DFS. And yeah, so some people are more comfortable running DFS. What I talked about before, where like with BFS, it's what the benefit of a BFS is that you can go layer by layer. So in terms of like, if you're trying to find like a shortest path, BFS is really great for that because you're kind of going step by step. And then, however, like if not, then DFS just might be easier to work with. Mm-hmm. Yeah. Okay, sorry. So with the examples I went through, I didn't really cover like how it would avoid not traversing the neighbors we've already visited. I kind of just wanted to outline what the thought process is with like how I can go from looking at a problem, thinking about that problem to moving on to pseudocode. So I'll kind of walk through what the pseudocode will look like. And in the pseudocode, I think when I'm pseudocoding out problems, that's when I'm also trying to ensure that I'm not traversing the same nodes. So someone mentioned the labels could have duplicates, right? So yeah, that's a possibility. So with the way I'm approaching it, I assumed that the labels uniquely identified the nodes. And for this problem, that was a fair assumption to make. You won't bump into problems like that, and that's fine. The way to go around the problem is that, so the way to avoid, like, let's say if the labels are not unique, what people are saying in the chat, right? You can pass the references to the node themselves to mark them instead of using the labels, which could have duplicates. So that's a good point to call out. But for now, I am assuming that the labels are unique. Yeah, that's mostly it. I'm making an assumption here to make it work in the case where there could be duplicate labels. It's pretty easy fix in terms of just substituting in the labels for like references instead. So just translating this, I'm basically implementing an iterative DFS. I'm kind of taking some of the logic we utilize there and modeling that in pseudocode. So I first create this label to clone nodes. We know from before that we need to somehow fetch the nodes we've cloned before. So in that case, I'm going to store a label to clone nodes mapping. The next thing is with iterative DFSs, you're basically explicitly modeling the stack. So nodes to visit will be the stack that basically contains the nodes I need to visit. So the first thing is we need to first create a clone of the start node, then update the mapping. And then after that, we kind of can run the DFS. So while there are still nodes we need to visit, so while the stack is not empty, we'll pop off a node off the stack. What we'll do is we'll fetch the cloned node associated with that node. And for each of the node's neighbors, what we'll do is if the node has not been created, what we'll want to do is we'll want to create that node clone. We'll want to also ensure that we update the label to clone nodes mappings, and then we want to add the neighbor clone to the stack. So basically what's happening here is this, if the neighbor has not been created, kind of acts as our visited set check, right? So if the neighbor has not been created, that means we basically have not visited that neighbor yet, if that makes sense. Does that make sense? Okay, cool. So we'll create that neighbor node, we'll add the neighbor node to the stack, and then you just want to make sure that at the very end where we add that kind of edge, that's the last step, where we'll add the clone neighbor to the clone nodes list of neighbors. So that's actually basically the pseudocode there. So the pseudocode doesn't actually outline like every single line of code you're about to write. It just kind of outlines a brief structure of what the actual code will look like. What's interesting with this problem is if you look at the code itself, it is not that different than what I modeled out there. So I wrote the code out in Python. The last thing I forgot to note is I need to return that last node. So I do store a reference. Well, I have a reference to that start node. So I just return the start node that I've cloned basically. So that's like the last step that I didn't include in there. But yeah, this is the Python code I wrote out for it. I'll have the solution posted on the week 1 tab after class. So I'll post this up. I'd highly recommend just kind of like reviewing through this code, trying to make sure you understand how it works. Actually, even before like looking at this code, I recommend if you didn't get a chance to finish it up to try to actually code it up yourself first. So even before looking at the solution, try to attempt to do the problem, because I think this problem is a pretty good like test of how well you can do like a DFS. And I think with debugging this problem, if you run into weird cases, it gives you good like graph debugging skills. Cool. So there are many, many different ways to actually do this problem. So this is just one approach. It's like an iterative DFS approach. So you might do a BFS if you want, and that could work as well. So with this, there was no right answer. It was just, this is one way to approach doing the problem. All right, so aside from that, I think the last thing you also want to be sure you're doing is you have to do like the runtime and space-time analysis. So in this case, we know that because we need to create a clone of the graph itself, that the space complexity cannot be better than basically the number of vertices plus the number of edges. So in this case, if we look at kind of the data structures we're using, we shouldn't exceed that limitation. So we have this label to node data structure we're using that will grow with the size of the number of basically vertices. We use, aside from that, we do have this nodes stack but that also shouldn't grow more than the size of the vertices. So overall, the space complexity of everything is kind of like O of the number of vertices plus the number of edges. And then the last thing is with time complexity, we're doing like a DFS and we're traversing through each vertex and each edge once. So for this problem, we're also doing for the number of vertices plus number of edges in terms of time complexity. Cool. Oh, someone asked, don't we also need to check if the node is already visited or not? The way that this was done is if you look at this if check right here, like if the neighbor value is not in basically the label to node kind of tracks what values you've visited, if that makes sense. So if you've already created a cloned value if you've already created a cloned version of a node, that means that you have either already visited that node or it's already in the stack so that it will be visited. So if you look at this if check right here, it says if the neighbor.value is not in the label to node mapping, it means that either it means that we haven't ever visited it or we haven't ever in-queued it to be visited in the future. So this mapping right here and this check right there does the visited set checking. Cool. So I think this problem is actually kind of tricky. It's kind of hard to figure out like what the proper way to model everything is. It's pretty easy to fall into a cycle when you're doing a problem like this. So it might look like deceptively easy, but I think when you try to implement it, I'd really just recommend you trying to implement it on your own and seeing like, can you get to the right solution? Doing this independently of looking at the solution, basically. So I'd highly recommend doing that because I think this problem is really good practice for graph problems in general. Cool. Aside from that, we have around 40 minutes left of class. I've picked out, I think, 2 problems that I think are pretty representative of pretty common graph problems that I'd like you guys to break out into pairs and try to do. So with the in-class exercises, we'll break you out into ideally groups of 2. There might be groups of 3 if there are issues. We'll try to spend around 20 minutes on each question. So for each problem, we're just trying to basically get you some more exposure to different types of graph problems to try to understand the problem, try to match it to what you know, try to at least like prototype and pseudocode the problem. And what we'll do is, because we're doing groups of 2, pick one person to share their screen for the first problem, and that person will also create that coder pad and do that problem on their screen. And then after that, you'll swap to the other person, where the other person will share their screen and work on the second problem. So the instructors and TAs will expect you to kind of have some examples, like have some pseudocode out before you try to implement it. We only have around 20 minutes per question, so that might not be even enough time to implement it. So at least get the pseudocode out there. So I just recommend moving on to coding if you have leftover time, and definitely share your screen. It takes a lot longer for me to have context when I jump into a room and I don't see your screen being shared. And just a reminder, if we pull up the tab right there, if we go to week 5, the exercises will be wrong session. Session 1, the 2 questions will actually be down here. So it's the word search board and the captured regions one. So do those 2 problems. And in terms of room logistics, when we break you out into rooms, stay in your room for at least a few minutes. Sometimes it takes people some time to accept the meeting room invite. So stay there, and only after a few minutes, if you feel like no one is joining the room, then do come back into the main room and we'll sort everything out. Cool. In that case, Elena, can you break out everyone into groups of 2?
Sure, I'll open the rooms now. They will be with their the old group. So
that's fine. Okay.
Yeah.
These 2 problems, I think one of the TAs called out that aren't really explicitly very like graphy. So I think from basically personal experience and looking at a lot of different graph, I guess, type problems, I think a bulk of the questions are just mostly BFS and DFS problems. So they're less so like explicitly you're given a graph. It's more that you're given a problem and you can run a DFS or BFS with that associated data structure. So with the word search problem, you can basically, it's a little more complicated than this, but you can basically effectively run like a DFS on the word grid itself. So I think the thing to know is like, I know some people kind of were considering modeling it as a graph and like duplicating the grid into a graph, but instead of having to create that additional data structure, sometimes it's helpful to think like, can I run a DFS with what I'm given and how would I structure it in that way? Aside from that, I think these two problems, I know word search is actually pretty common. So these two are like pretty common questions that could be asked in an interview. So I think we didn't really give you that much time to complete the problems, but I'd highly recommend going back and trying to do the problems, trying to code it up, because they're really common questions like these types of problems. And they might even just be questions you'll see out in the real world in real world interviews. So with that being said, actually, in regards to like the three questions we looked at together in class, the clone graph problem, the word search problem, and the region capture problem, they're all kind of like that LeetCode medium level difficulty. So that's kind of where a lot of interview questions will be, in the medium level difficulty. So with regards to these three questions, what I'd say is probably in the setting of like a 45-minute phone screen or 45-minute interview, you'll be kind of expected to get to probably finishing up the code for that problem. So it's kind of expected that this is the type of problem you should be able to handle in one interview session, basically. So that's kind of like, I think, the right expectations to set in terms of what type of problem you'll see. I think these are super, in terms of level of difficulty, these are pretty common to like what you'll be seeing in interviews. Cool. So highly recommend going through these problems. They're pretty common problems. Aside from that, I'll add solutions to the in-class demo, and I'll add a link to the slides to the session 1 tab. Either, I think I have to clean up some of the slides, but I'll try to have them up as soon as possible. Just as a reminder, I have a video walkthrough if you kind of want more practice with graphs. Aside from that, I know Greylock, what Greylock does every year in the Bay Area is they'll hold like a tech fair and you kind of apply to get in. So just wanted to call out that the tech fair is also happening this year, and the application to apply is July 21st. So I think to apply, you probably have to submit your resume. So there are a lot of resources. You feel free to reach out to the TAs if you want your resume reviewed in time for this deadline. I'd highly recommend the tech fair. I've been before. It's just a great place to be able to, I think there are like a ton of like small to big companies that'll be at this tech fair. So it's a great place to learn about these different companies and put your resume in. Aside from that, I just wanted to let you guys know that I was able to get some of the emails from the panelists from 2 weeks ago. So I posted their emails in the general class Slack. So if you want to email them about specific questions you might have, feel free to reach out to them. They said they're open to like answering questions, and they gave me their email for that purpose. Yeah, aside from that, I'll kind of stick around after class, answer any questions people might have. I'll stick around for like the next 10 minutes or so. Yeah. Sorry. Cool. Oh yeah, sorry. I'll also post a link to it. Okay. I'll post a link to it in the class, and I'll like ping people about it and let them know. Cool. Did anyone have any questions? I'll just be here, and if there are no questions, I'll head out early, but I'm also have time. Someone asked, what category do people list side projects under? What I've tend to see is really common is people will put like kind of their education first, and then they'll put their experience next, and then they'll put their last section as like the project section. So people separate it out generally. Yeah, there might be more sections. Like I think I'm missing like the skills section. So I think people will also tend to have a general smaller section on skills. Any other questions? It can be about anything related to graphs. Yeah, so someone asks, can we get the traversal code in Java as well? I will try to get that out in Java. Yeah, so I don't currently have that on the guides or anything, so I'll try to add those in. And someone said, yeah, so I think having a specific section labeled projects is fine. Yeah. Oh, one of the TAs brought up a good point. If you have a GitHub link to the projects, I highly recommend linking it in the PDF of your resume. So what happens is like as an interviewer, I'll get resumes on like digitally, and I'm able to kind of click through links. So having those in are great. Okay, let me go through and answer the questions because a lot of them just popped up. Quick question about word search. I understand that you could use DFS to solve a problem, but how would you prevent, I'm guessing, it from going back to the letter of origin? So I guess when you're doing like a DFS, you'll start off with like maybe like, let's say the first letter at the top of the grid. You are, I believe with the problem, you're just not able to, you're not supposed to go back to the original letter. So you can traverse into like vertically and horizontally. You should just not repeat yourself, if that makes sense. So you can actually end up going back to yourself if you've taken a step. So the idea is that you need to make a step each traversal, but you can't like stay on the same letter multiple times. That's the idea. Yeah. Let's see. Okay. Is it okay to list bigger projects we did in our classes if we don't have that much experience? Yes. Yeah. So I think it's fine. Ideally, I think with class side projects, if you don't have anything else, I think go ahead and list them. Ideally, if you have your own personal projects that you've done, that tends to be more unique and that helps you stand out. So I think if all else is like, if you don't have any other experience, just add those side projects and that's fine. Mm-hmm. And someone said, yeah, so for the session next week, we're gonna briefly talk about topological sorting as like the beginning of the lab section. So I think for topological sort, I'll also keep an eye out for the Java code as well for that. Cool. Any other questions? Kind of let people. Oh wait, sorry. I'll like stop sharing. Yeah, that's interesting. I think with their current internship, I know some people are kind of like at the halfway point. I think what's probably more helpful is just you can put a bullet for it and then just like probably list out the team you're working on, maybe what project you're in the middle of working on. I think like basically disclose as much as you can. Like, are you doing a full stack role, back end role, front end role? Like, if you're doing machine learning stuff, are you doing that? Write that out. Maybe talk about the technologies you're using so far. At this point, you're probably just starting out in your internship, so write as much as possible and maybe write like what project you're currently working on. So that's how I would approach adding in my current internship. Yeah, one of the TAs made a good point. I think when you're kind of in the middle of a project and you don't know what the impact is, maybe it's always good to, that's a really good tip. I think it's always good if you can to write out the impact your projects had. So for example, I implemented X project, which led to a maybe, which helped people like debug their code better or like something like that. It's always, I think, good to tie in projects with like the impact you've made. So I guess that's more applicable to past projects, but even with current projects, if you know kind of what the project will look like, you can explicitly write out like currently working on this, which is meant to do this. Yeah. In regards to the Greylock Tech Fair, I don't really know the specifics of it. I think they'll talk about it on the site itself. I'm not really associated with organizing it or anything, so I don't really know the details. So all I know on the site is that it says it's in Oracle Park in San Francisco. So I'm not really sure like what else they'll provide with that. And then I actually don't really know what a dev post link is. Sorry, I'm not really familiar what that is. But I think some form of a link is always great. So if you have the actual site that's being hosted, put up a link for that. If you have the GitHub for it, put up a link for that, whatever. I think having a link is better than no link. Cool. In that case, I'll be here on Saturday for the kind of like mock interview sessions, and I'll see you guys then. If you have any questions, feel free to Slack me. I'm pretty responsive on there as well. Bye guys, see you soon.